Hey Squad, in this video we're going to keep on going with our hypothesis testing. So we're just continuing what we already know. So in this first exercise here, we're talking about in a recent year, 73% of first-year college students responding to a national survey identified being very well off financially as an important goal. A state university finds that 132 out of an SRS of 200 of its first-year students say that its goal is important. If there good evidence that the proportion of all first-year students at this university who think might very well off differs from the national value, correct the given work. So I'm telling you, amongst this, there is a lot of hot mess situations. I would like you to take a moment, pause the video, try this out, especially if you're in class with one another. Talk it through, see what stands out as a problem to you, and then I'll regroup and kind of come back into forward with you. Okay, welcome back. So, lots of red flags that should have been noticed on this. So, the first thing that really always resonates to me is that I was stressing in the last video that we had, or in our first lesson, this situation where the null hypothesis and the alternative hypothesis, anything in general really, all of these, that should be based off the true P. So coming back and looking at it, 73% of first-year students responding to a national survey identified as being off. So that's all based off of national information. This is your true amount, but it's P. So that's your 0.73 is P. So while the 0.73 is good, that should all be P equals. It's always based off your true proportion. Okay, so that's my big red flag. I see that one from a mile away, right? So that's big. As I kind of keep going through this here, I think that's the only thing that's wrong with the hypothesis statement. I would also add in the true proportion when I start to talk about that parameter. Yes, it's necessary to include the parameter. That's another big one in there. And then as I go for our SRS is given, great, we love that. And as I kind of make my way down here, I notice we have another issue. Right, when I look at this here, T, our conditions here. So 132 is greater than 10%. Well, we've never talked about that. So there's a couple red flags in that scenario for us here. So as I look at that, we know first off that it's supposed to be N is less than 10% of whatever that population is. That's capital N. If I come back to my context here, 132 out of 200, that means my P hat is 132 out of 200, meaning that N is 200, and 132 is just the success. So also, it should be 200 is less than that 10%, and the context does match, so that part's okay. But that's two red flags right in that T checkpoint. You don't have to write I/T, like, as long as it's getting the point across here, then that's it as well. And then that being said, in there, continuing to look, LN. Well, here, again, my P hat, that's probably about equivalent to that 0.66 that we're getting here. I don't want that in here. We'd want P, the true proportion. Like that part of it is supposed to be NP is greater than or equal to 10. NQ is greater than or equal to 10. So I should be looking at N times 0.73. And really that 200 times that 0.73, right? And 200 times that 0.27. That's what I should be looking at as my large enough. And then we can make some kind of statement of how my conditions are satisfied, remembering what each condition does. The randomness allows me to assume there's no bias, that it's appropriate for my population, 10% that it's independent, and then ln that's large enough for us to assume that it's approximately normal to use the normal model. And then we mosey our way down to the calculation where we see our picture, which is definitely great that it's there. But one big red flag before that calculation should have even started, before that calculation should even in the remote business take place, is there should be some mention of that we are condition satisfied for a one prop Z test. Again, over everything else, this is where I'd be the most frustrated for a student to lose a point. Right? You won't want to go from an E to a P on an AP question because you didn't title it. If you can do all the calculations, it means you very well know what type of testing it is. Make sure you make mention of it, right? Get into the habit now. So while the normal model is labeled, that's great. Very happy about that. There's also another problem here. 0.73 is great. 0.66 is great. But this is an issue we didn't really come into the other day. This not equal to idea, it's been a minute. When you have your alternative being not equal to, well, I see my standard errors put in play. All of this checks out, but technically the same distance away. So 0.66 and 0.73 away, we're talking about 0.07. So if I add another 0.07, get 0.8. This should be shaded as well for a two-tailed test. So when you see not equal to, two-tailed hypothesis test is in the mix. Now we did that way back in the day. We haven't seen one of those in a little bit, but that still holds up the same as it did in the beginning of the year. Okay, so that all checks out. Now, I can double check my math here. I'm not 100% sure with it, but I'm going to come and just bring in my calculator for a quick moment. I'm going to add myself a fresh calculator page for today's stuff. So we're looking at that calculation just to double check. My 0.66 is my sample minus that 0.73 all over. It does say a 0.031. I do believe that's correct. Let's just double. Might as well do our due diligence though, right? So square root 0.73 times 0.27 all over our 200. Cool, that does check out. So then back to what we were doing. The 0.66 minus the 0.73, and I'm okay with the rounding here, so the 0.031 negative 2.258. All right, the z-score is good. All of that checks out. I like the way they showed the math that comes into play there. Now, when I go and do the norm CDF from here, stats, distributions, norm CDF, my lower bound is going to be that negative infinity up to my negative 2.25806 that I'm looking at right there. Enter, okay. So I've got this amount, which checks out to what we had. However, that only gets me the amount from here to here. when I do my norm CDF like so. Remember, a two-tailed test, you've got to take this value and times it by 2 to finish the job there. So when I look at my p-value and toss that into play, a nice times 2, I should have something roughly around this. Oh, it looks like they were missing a 1 in the other spot too, now that I look at it. They might have got that from putting in rounding. Let me just double check. That might not have been a big issue, but let me just make sure I can double check with them. Stats. Oops. Stats, distributions, norm CDF. Let's say I put in that negative 2.258 like the person did. Enter. No, they still got the same about. So it looks like they were missing a 1 that I almost missed. So this should technically be 0.0119 times 2. And that's what's going to get us the real p-value of about 0.0. 0.0239. So there's our p-value. And then it says, because my p-value is low, solid, I failed to reject. Now this is the difference here. When I am looking at these low scenarios here, right? Low gotta go. That's what you're thinking about. If it's low, it's gotta go. You've got evidence to reject, my friends. So failing to reject is something that's not unusual, right? It's just like that's common. Low gotta go. So because my p-value is low, I failed to reject HO. Low, HO. I don't have evidence. Now I do have evidence. That's the whole point. I have evidence to support that I'd add the true proportion in there of students who agree is not equal to 0.73. That not equal to idea comes into play. This is like where it's like orgs extreme as, but really it's that if it's low, gotta go. It didn't mention what the confidence level was, right? I don't think it ever said, so we can assume that it was a 95%, meaning an alpha of 0.05. So being less than that, that's when it's gotta go. You've got your evidence there, my friend. Okay, so hopefully you picked up on most of these. And if not, you're going to get better with the more practice we do. So kind of going forward with what we're seeing here in this case, we want to know what the p-value is. So the p-value is, of course, something that we really need to understand exactly what it means. So as I go and kind of talk about that, the p-value is basically is saying, given that the true proportion of students who agree with the statement, we observe a sample proportion at least as extreme 2.4% of the time. So let's talk about that a little bit more, right? So when I think about this, the p-value is based off us having that true proportion, right? So right now, it's the idea that based on the true proportion being 0.73, right? And of course I would add context based on the true proportion of students who agree with the wanting to be well off financially. So based on that being 0.73, we observe a sample proportion, which us ended up being that 0.66, or you can write it as the 132 out of 200. So we observed our sample at least as extreme. Now, this wording, that at least as extreme, comes into play because of the idea of that not equal to. So that's what that's for. Because it's not like you're saying as great as ours, as low as ours. Like, it's not like an easy less than or greater than. So the extremes count for both tails. So that's the kind of idea. And that's what we got, this 2.34, right? So it ended up being that 2.4%. That's where we ended up getting that amount from. So that's what the p-value is in context. Assuming that our p is true, we get a sample proportion as ours 2.4% of the time. We've been saying it for years and years. Maybe not years and years. We've been saying it for like the beginning of the year till now about what that probability means, what that p-value's been this whole time. I guess years is an exaggeration. But we've been saying that frequently. This is us just putting it all together now. And then what is the alpha level, the threshold for rejecting? So this is where we come into play again and kind of talk about this alpha level. So alpha can be whatever they state it to be, right? An alpha level could be this 5%. Like I said, this is your popular one. 95% is it's affiliated with it. So think about like that 95% confidence. If it didn't fall within that window, 5%'s left over. It's a little too rare to happen by chance. Same idea here. If your p-value is less than 0.05, we reject. Same thing over here. My alpha level could be 0.01 depending on the question. So if my p-value is less than, we reject. Excuse me. So with those two, it could change based off what we have. The question completely changes. Like if I change my alpha to 10% or to 0.01 in this case, now I wouldn't have rejected, right? This would have been above. It might be slightly above, but based off that alpha level in here, when I think about it, so we did reject. That's what we did already. In this case, with this 2.4, we would fail to reject here. And it's okay either way. All right, so in this next one, if my null hypothesis is p is equal to 0.5 and the alternative is p is greater than 0.5, given z is equal to 2.19, what conclusions could we make? So never forget that what this is at the end of the day is still your norm CDF. You don't want to get too comfortable with the fact that your calculator can do all of your hypothesis testing for you, because again, at the end of the day, you still want to know where it comes from. So my idea with that tells me to come right on back to our norm CDF. If you have a z-score, we're using that in our norm CDF. And when I think about this, we're doing z is greater than 2.19. Because if you think about it, if I think about the context here, remember the the alternative hypothesis is setting a lot up for us too, where when we think about this, 0.5 is what we assume to be true. We're getting this 2.19 as my z-score. That is going to be, if this was technically 0, right? 2.19 would be somewhere over here, and then that greater than is going to shade to the right. When you find a z-score, if it's positive, it's going to be on the right. If it's a negative, it's going to be on the left of wherever that mean is when you think about it. So as I do such and I come back in, menu, stats, distributions, norm CDF, my lower bound is going to be changed to that 2.19. You can put in infinity or your 99999, and I get that 0.014262. So there's our p-value now. That's what I've just found. And when I compare it to what I'm looking at here, right now, it's less than 0.5. So if my alpha level is that 0.05, 0.05, sorry, that. My conclusion is now going to be because my p-value is low, we reject HO. We have evidence to support P is greater than 0.5. The alternative in that case, right? And usually it's context-based, but we can make our way off of that. If I do the same thing and compare it here, now when I'm looking at that 0. That is greater than my 0.01 alpha level. So now, because my p-value is high, and now I'm with you, it's not that like the p-values change from high or low here, but when I make that statement of p-value being high, it's higher than the alpha. That's what I mean by high or low. It's comparative to the alpha level. We fail to reject HO, that no, we do not have evidence to support P is greater than 0.5. And again, context would really come into play in that case in there. Excuse me. Okay, so we can quickly make a nice confidence interval of 95% for the proportion of students at this university who think that being well off financially is very important. So of course I'm going to bring in my pieces. I don't have to go through all my conditions since we already satisfied them before. My confidence interval is going to be p hat plus or minus my critical z with my p hat, q hat, and n. You've already shown all of those pieces, but I'm plugging in my 95% is that 1.96. Remember, you could do your inverse norm to get that if you need to. Now, remember, too, I'm back to interval, so sample is everything in this interval. I'm bringing all the p-hats back into play. So with this, when I plug this in, a quick little reminder, I can do it by going into stats, confidence intervals, 1 prop z interval. My success was 132 out of the 200. And then as I do this, I see my p-hat of 0.66. I see my n, my margin of error, my lower and my upper bound all there. So we built a confidence level of 0.594 and 0.724. Now, while it's closer, I guess this was 6, technically. It's close. It's quite close. But, you know what's not inside there? 0.73, that true proportion does not fall within the interval. So ultimately, we would have had the same conclusion, right? We would have said that while I came back here, if I look this, my p-value is low, I reject HO. I have evidence to support the true proportion of students is not that 0.73. And then for my sample even, when I take my sample and build an interval, 95% confidence, it does not fall within our interval. So again, I would have said that this is not falling within it. Now, the thing to keep in mind is 95% confidence means the rest of it, when I think about it, has an alpha of 0.05. Let's talk about why. So imagine I'm building 95% confidence. Just like we did when we built a confidence interval, that meant that 2.5% was left on each side. So this rejection area of my confidence interval is the same as when I have an alpha of 0.05 or 5%, right? It's that same amount. I either build my hypothesis around it, or when I have this 2 sample here, it's that same idea. I could take that a step further and think about 98% confidence. Okay, so if this is 98%, that piece left over is 1% for each, but that 1% left over means I have an alpha level of 0.02. It's whatever's left. So no matter what, it's all connected to the idea of wherever I make this amount, right? That 1 minus C is going to be making up these shades. So if you have a 2-tailed test like I've been showing here, 1 minus C is going to be what my alpha level is. The confidence interval and the hypothesis testing are essentially the same thing, but doing it in different ways and understanding that difference. Now, the only other thing is if this was a 1-tailed test, so bringing it back to my 95, while there's 95% in here, let's say I'm doing less than. Remember, this was only 2.5%, the other 2.5% is over here. Now my alpha is just this 2.5%, or the 0.025. Same thing, 98%. But the alpha is just that 1% or 1.01. So the part that changes here for my C is now whichever tail I shade, right? It's like this 1 minus C divided by 2 when it's a 1-tailed. Okay, so that's a good amount of everything we're going to need to know. There is an AP Classroom attached to this one here just to kind of make sure we're on the right page with everything on this. And hopefully for the next lesson, we'll be able to regroup in person. Thanks for watching, guys.